now we're gonna talk about power series. First, we're gonna find the power series of some transcendental function. For now, we're gonna find the power series of sine x. So we all know that if you search it on the books or in the internet, we will come up with the power series of x minus 1 over 3 factorial x times x raised to 3 plus 1 over 5 factorial times x raised to 5 minus 1 over 7 factorial times x raised to 7 plus dot dot dot. It means it's continuous. So where did we come up with that equation? First, the function of x is equal to the function of a plus the function of a prime over 1 factorial times x minus a raised to 1 plus the function of a double prime over 2 factorial times x minus a raised to squared plus dot 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 dot. So in here, we're gonna assume that the function of a is equals to sine x and the value of a is equals to 0. So we're gonna use now the Maclaurin series. So sine x is equals to f of 0 plus f prime over 1 factorial times x plus f double prime over 2 factorial x squared plus f to 3 prime over 3 factorial times x raised to 3 plus dot 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 dot. So we're gonna find the first 5 terms of the sine x. So we're gonna have from f of a to f 4 prime. So the f of a is equals to sine x. So the derivative of it is cos x, and the derivative of it again is negative sine, and if you derive it again, it is negative cos x, and if you derive it again, the answer is sine x. So it just came back. So if you substitute the value of a, or which means that a is also equal to x in here, just like I did, so I'm so sorry. So if you substitute a from 0, like in here, so sine 0 is equals to 0. And cos x or cos 0 is equals to 1. Negative sine x, negative sine 0 is 0 again. Negative cos 0 is negative 1. And sine x is equals to 0. So in here, we're gonna substitute these values in here, in this equation. So if you substitute this f of the function of a and to 0, so it's just 0, so you don't have to write it now. And if you substitute the function of a prime, which is equals to 1, see, and then the value of n 1 minus plus the function of a double prime, which is equals to 0, so we don't write it again, so because it just equals to 0. The next is the function of a 3 prime, which is equals to negative 1, so negative 1 over 3 factorial x raised to 3, and then the 4 is 0. So to assume that you can see a pattern in here, you can assume that the next series, the next factors are plus 1 over 5 factorial raised to x to the 5 minus 1 over 7 factorial times x raised to 7 plus dot dot dot. As you can notice that the factors are in even or odds number. No, 1, 3, 5, 7, etc., etc., etc. So if you notice that it is just the same in here. If you look closely, this is 1 over 1 factorial is just 1 times x raised to 1 is x. So how did we come up with that? So therefore, sin x is equals to the summation of n is equals to 1 to infinity negative 1 raised to n plus 1 times x raised to 2n minus 1 over n factorial. So that in here we can get an odd number, and so in here too we can get a positive and negative. So this is the power series of sin x. Thank you.